Okay, hi there. Hello, and welcome to our next discussion. This will be focused more on the measures of central tendency and the measures of dispersion. So, this is very much important because this is useful in statistics. Let's talk first on the measures of central tendency. An average value, when you talk about measures of central tendency, it's an average value within the range of all the entire data that is used to represent all of the values of the series. So, it has only three. It's actually composed of three lang. Pag moingon kita, what are the measures of central tendency? We only have the mean, the median, and the mode. So, we'll try to talk about this one by one. Let's have first the mean. The mean is the most common method of central tendency. Okay, if you have read research papers, so ang mean gito ang pinakasikat na measures of central tendency in making an inference or in making a conclusion about the population in a particular study. So mean is computed by dividing the sum of all the values by the total number of values. It's represented by bar x. We have three actually. Ang computation sa mean nato mag-differ if it is from a discrete data, from a discrete frequency data, or a continuous frequency data. But they are actually using the same formula lang. X is equal to the sum of all the values of x or the summation of x. Kung i-expand nato ning si summation of x, it simply means x of 1 plus x of 2 plus ellipsis until x sub n. So kaning ellipsis, these are the values between x sub 2 and x sub n, such as x sub 3, x sub 4, x sub 5, and so on. Then you divide that one by the total number of observations or values. Okay, let's try to compute the mean for a discrete data. For example, the hemoglobin levels of 10 women are given by 12.5, 13, 10, 11.5, 11 until 12. So we will calculate the mean for this data. Now, basically, we will be adding all the values. So 12.5 plus 13 plus 10 plus 11.5 plus 11 plus 14 plus 9 plus 7.5 plus 10 plus 12. This will give us 110.5. And then we divide it to the total number of observation. In this case, there are 10 women, so it has 10 corresponding hemoglobin levels. And if you are to check, there are 10 data in this given example. That's why we have 10. So 110.5 divided by 10, this gives us 11.5. This only means that the expected hemoglobin levels of women are 11.5, or the average hemoglobin levels of women are 11.0.05. Okay, now let's calculate for the mean from a discrete frequency table. Kilayan ninyo pag discrete frequency siya if it involves frequency na or the number of occurrence. Maingan kita frequency, that means the number of occurrence or the number of existence, the most frequent. Okay, so you have there x or the mean is equal to the summation of f times x divided by the summation of f. X corresponds to the value of the given variable. F is the frequency of the variable. Okay, again, frequency, that's the number of occurrence or kapila, how often. Okay, for example, um, what's the frequency? Let's change this one. I have in here digits like 2, 6, 4, 2, 7. So asa may nagbalik-balik diri ana number, we have 2 only. So 2 is the most frequent digit. But later you will learn more about this one pag discuss dato sa mode. Let's focus first on the mean of the discrete frequency data. For example, you have there the age of 100 girls. Find the mean age or the expected age, the average age. Kaya kung moingon kita na mean, it is sometimes called the average man or the expected value. So we use this formula and then we have the table. On the first column, these are the age of the girls or the variable x, and then it has its corresponding values. Second column, it's the frequency or the number of students. Third column, it's the product of the values here in the first and the second column. So when you read this one, there are 35 students who are 16 years old, 31 students or 31 girls are of age 17, 20 girls are of age 18, and 14 girls are of age 19. So we will be adding this one. The answer or the total is 100. Then we multiply 16 times 35 because we have here x times f man. So 16 times 35, that's 560. 17 times 31, that's 527. 18 times 20, that's 360. 19 times 14, that's 266. Still, we will be getting its total value, so that gives us 1,713. Now, the next thing that you will do is to substitute these values to the formula. Summation of f times x, that's 1,713. Summation of f, that's 100. So dividing this, you will come up with 17.13 years. So it only means that the expected age of girls is in that particular study is 17 years, or the average age of the girls in that study is 17 years, or 17.13 years. Okay, what about the mean for the group data? How do we calculate this, or the mean for the continuous frequency table from the continuous frequency table? We still have the same formula, but in this case, x is the midpoint of the class interval. F is the frequency of the class interval. So how do we get the midpoint? Basically, you add the lower limit and the upper limit, and then you divide them by 2. Okay, let's start. The first column, you have here the x or the intervals. Second column, that's the frequency. Third column, that's the midpoint. Fourth column, that's x times f. Okay, so there are 15 people who are of age 15 to 20, 20 people who are of age 20 to 25, 40 people who has the age ranging from 25 to 30, and 60 people has the age 30 to 35. So these are the frequencies. You will be adding this. You have then 135. Now, we first have to get the midpoint para makuha nato ang fourth column, ang values ni fourth column. So to get the midpoint, again, lower limit plus the upper limit divided by 2. So 15 plus 20 divided by 2, that is 17.5. 20 plus 25 divided by 2, that's 22.5. 25 plus 30 divided by 2, that's 27.5. 30 plus 35 divided by 2, that's 32.5. Okay, now that you have the values on your third column, you then proceed to the fourth column. So 17.5 times 15, that's 262.5. 22.5 times 20, that's 450. 27.5 times 40, that's 1,100. 32.5 times 60, that's 1,950. Then you add this one again, and then you have here 3,762.5. So once you have these values, directly substitute. Summation of x times f, that's 3,762, divided by summation of f, that's 135. So if divide that one, the answer is 27.87 years. It means that the average years in that study is 27.87, or the expected age of the respondents in that study is 27.87 years. Now, let's talk about the advantages and the disadvantages of the mean. So, let's talk first on the merits or the positive things about the mean. It is simple, average, and easy to compute. Okay, so the mean is easy, it can be easily computed, di ba? So, i-add lang nimo tanan values divided by the total number of observations, then you have it already. Next is, it is affected by values of each item in the series. So, ang value ng imong mean magdepende sa values ng imong observation. Okay? It is fixed mathematical formula and always gives the same answer. On the other hand, the mean has a very small and very large items which usually affect the values of the average. Say for example, your data here is kani ang grades imong mga bata 75, 70, 65, 61, and 99. If you are to compare this one, 99 here is much higher compared to the other data. So pag compute nimo ana ng mean mo, dako pod ang value niya. Pero kung si 99, i-change nato ni siya into, let's say, i-change na lang nato ang entire data. Let's say, ang grado sa imong mga bata is 99, 97, 96, 95, then you have there 60. Okay, so this datum is much smaller compared to the other data. Then, muubos pod ang value ng imong mean. Okay, that's the advantage, the disadvantage about the mean. Kaya it is affected by each datum in your observation. The mean cannot be computed in case of open-ended classes with no upper limit and lower limit. That's another disadvantage. And at the same time, it's not a good measure of central tendency because then again, maapektuhan, magbago-bago ang value ng imong mean if the datum differ from each other or dako ang diferensya sa kada datum. Next is the median. It's the middlemost value. Okay, the middlemost value when the data is arranged in ascending order of magnitude. It divides the observation into two equal parts, the left side and on the right side. Okay, so one half will have items larger than the median value, and one half will have the items smaller than the median value. This is denoted by a capital letter M. Okay, for example, you have in there the data 158, 167, 143, 169, and so on. So this is the weight of the person in pounds. Now to get the media, you have there the formula. This might confuse you. This should be the quantity of n plus 1 divided by 2 equals the nth observation. Okay, so let's arrange first. The first step in getting the median is i-arrange sa nato ang data in ascending order. When we say ascending order, you start with the smallest value up to the highest value. So na-arrange na, you will then use or apply your formula. Okay, you have n plus 1 divided by 2. And here is the number of observation. So bilangon lang nimo kung pila ka datum ang naa or pila ka value ang naa. In this case, we have 1, 2, 3, 4, 5, 6, and 7. So n is equal to 7 plus 1 divided by 2. 7 plus 1, that's 8 divided by 2, that gives us the fourth observation. This means that the median in this particular example can be found on the fourth observation. So bilang kita from the first data, a datum. So 1, 2, 3, 4. The fourth observation is 158. Therefore, 158 is our median. And from here, you can see that we can prove as well na tinuod ang giingon na one half will have the items larger than the median value. So kaning diri sa right side, these values are larger compared to the median value. And on the other side, these values are smaller compared to the middle value or the median. Okay, take note if n is an even number, add the values of the observation before and after the fraction result and divide by 2. So, for example, you have there 3 plus 4 are your middlemost values, your two middlemost value. You add them, you divide by 2, 3.5 will be your um, median. So, basically, kung ang number of observation nimo is odd, pasabot, bungkig, imo lang siyang i-arrange in ascending order o niya ang naa sa tunga will be its median. For example, na kay let's say 65, 70, 75, 80, and then 82. So this is already in ascending order. Ang n nato diri is 1, 2, 3, 4, 5. 5. So 5 is odd. Now, you just have to group this one unya ang naa sa tunga will be your median. Pero, kung let's say, um, payaon tani, let's say even ang imuhang for a while. Okay. Kung even ang imuhang observation, so this is 75, let's say naa kay 60. Kung even, so ang naa sa tunga, right? Ang naa sa tunga nimo na values are 70 and 75. Even na siya kay 1, 2, 3, 4, 5, 6 man. So, imong buhaton is to add, okay, for a while, calculator, is to add 70 plus 75 divided by 2. That gives you 72.5 is the value of your median. Okay? Now, what about the median for the discrete frequency data? Still, same lang gihapon ang formula nato, okay? M is equal to the quantity of n plus 1 divided by 2 is equal to the nth observation. First step is to calculate the cumulative frequency. So, ang cumulative frequency is just the sum of all your frequencies. Okay, i-add lang nimo tong frequency sa kada um, data, sa kada datum rather. And then you consider the final cumulative frequency as the value of your n. And then you calculate for the median. The value of the observation will be in reference to the cumulative frequency column. In case the calculated M does not exactly match with the cumulative frequency in the table, the next higher cumulative frequency to the calculated M may be considered as an observation for the median. Okay, let's have here an example. Calculate the median for the following frequency data or table. First row, this is the income per day of the people. Second row, it's the total frequency, the frequency. And then third row, it's the cumulative frequency. So when you try to read this one, 5 people has an income of 100 pesos per day. Let's say it's in pesos. 19 people has an income of 150 pesos per day. 3 people has an income of 200 pesos per day, and so on. So to get the cumulative frequency, i-add lang nato kaning frequency diri as a second row. So 5 ang initial plus 0, the cumulative frequency is 5. Then second one, 19 plus 5, that gives you 24. 24 plus 3, that gives you 27. 27 plus 11, that gives you 38. 38 plus 6, that gives you 44. 44 plus 9, that gives you 53. Now, kaning sa second row, given na ni siya sa imong data na gi-collect. No? Now that you have this already, ato na dayon i-substitute sa atong formula. Take note, if the data is for discrete frequency data, ang n nato is not the number of observation, but it's the total or the cumulative frequency. In this case, ang cumulative frequency or the total frequency is 53. So n is equal to 53 plus 1 divided by 2, that gives us 54 divided by 2. So si 54 nato divided by 2 gives us 27 or the 27th observation. Pasabot, ang ika-27th observation niya will be at our mean. So in this case, the corresponding value or x here is 200. Therefore, the median, the median rather is 200. Next, what about the median for the group data? So in case of continuous frequency table, the median calculated, the median can be calculated with this formula. The median is equal to n divided by 2 minus CF all over F times W plus L sub n. Ang n nato is the summation of F or the total frequency. CF is the cumulative frequency, which is sometimes denoted as the small letter n, or the cumulative frequency of the class just before the median class. F here is the frequency of the median class, W is the width of the class, and LM is the lower limit of the class. So we'll try to write it down here. Can I write it here? Or can I actually paste this for a while, huh? Let me take a screenshot of this. I can't. Shift S. Dili pwede. So, ibutang na lang nato. 3C. Formula. Okay. M is equal to n minus 2. Let's make it cap it that. Okay, m is equal to, let's do it again. I think I need a much bigger screen here. Okay, so m is equal to n minus 2. N over 2 minus CF. Okay, n over 2 minus CF. N over 2 minus CF divided by F, okay, times W minus the lower limit. Okay, there you have it, or L sub M. Okay, so in this example, calculate the median for the following grouped or frequency data. The first column here, the first row has the income per day or the variable X, and then the second row here is the frequency or the number of people that corresponds to a certain income per day. Then for the second illustration or the second table, we already have the cumulative frequency. So 5 plus the initial, 5 which is the initial plus 0, that's still 5. And then 19 plus 5, that gives us 24, plus 3, that's 27, plus 11, that's 38, plus 6, that's 44, plus 9, that's 53. Okay, we'll go to our solution right now. Using the formula, this is n plus 1 divided by 2 is equal to the nth observation, where n is equal to the cumulative frequency. Okay, so we'll try to use this formula. Our cumulative frequency, dari na lang, is 53 divided by 2. Gikan ni sa kaninga table, no? This is our cumulative frequency. Minus, sorry about that, minus our CF. So in this case, our CF, okay, cumulative frequency of the class just before the median class. Okay, this is our cumulative frequency just before the median class. So the median here is on the 27th observation. So ang atong cumulative frequency diri is 24. So we substitute 24 in here. Okay, 24. Then using the formula, we divide that one by F. Our F here is, in this case, F is the frequency of the median class. So our median class has the frequency which is 3. So we have it in here, okay, 3 times our width. Ang width nato or ang width class nato in this case is 150 minus 100, 200 minus 150, 250 minus 200, 300 minus 250, and so on. That gives us 50. So we will put it here, 50. And then plus the lower limit of the median class. So plus the lower limit of the median class. Ang median class nato diri is on the 27th observation. So we have the lower limit, that's 200. The upper limit, it's 250. So ang atong i-add is 200. Now, if you are to simplify this one, diretso na lang nato, you will come up with 241.7. Okay, so that means the median in this particular example is 241.7. Now, what are the advantages or disadvantages of the median? Let's talk first on the advantages. The median is useful in case of open-ended and unequal classes, just like what we had. Extreme values do not affect the median. No? Kung sa mean, maapektuhan ang value ni mean kung gamay ang isa ka datum compared to the other data, or mas dako ang isa ka datum compared to the other data. Pag abot diri akong median, it won't matter. That's why I think it's the most the safest, no? Okay, for example, na akay ang imong data is 10, 2, 6, 7, 90. 8 unya na kay 150. So we'll arrange this one in ascending order: 2, 6, 7, 10, 98, and 150. So we'll group this one. Okay, we'll group this, and then ang middlemost value nato is 7 and 10. So ato lang i-add 7 plus 10 equals 17 divided by 2, that's 8.5. No? Maski pa naa kay 1,000,000 o 3,300,000 one sa imuhang data, dili mautro ang value ni median. So that's one of the advantages, and it's most appropriate in case of qualitative data. At the same time, it can be presented graphically. On the other hand, arranging data in frequency is required. Of course, no? Kay ang sa formula nato, need man si frequency. So you have to construct a table para mas malantaw nato ang numericals. Median is not generally calculated for quantitative data since it's not useful in further algebraic treatments. So si mean, it's better for quantitative data, while median is much better for qualitative data. Okay? Now let's move on to the mode, which is the third example of a measure of central tendency. The mode is the value which is or which has the highest frequency, ang pinaka nagbalik-balik na data sa imuhang observation. This is denoted by a capital letter Z. For example, calculate the mode of the following discrete data. Okay, so ato lang tawon. So ang 1 diri how many times did it occur? In this example, 1, 2, kaduha lang. And then we have 7. The number 7 occurs how many times? We have 1, 2, 2 gihapon. Then we have the number 4. How many times did it occur? So we have 1, 2, 3, 4, 5, 6, 7. And then we have another digit which is 5. So how many times did it occur? You have 1, 2, 3. And then we have one more. Okay, 9. How many times did it occur? So 9, 1 lang. And then we have number 6. It occurs once lang gihapon. So if you are to take a look at it, ang pinaka nagbalik-balik na number diha is number 4. So it's the most frequent datum in the given dataset. Therefore, it is our mode. Inyo lang dumduman pag si mode, it's the most frequent or ang pinaka nagbalik-balik nga number. Okay, let's have here the mode for discrete frequency data. Calculate for the mode. In this example, we have the income for the first row, the number of people or the frequency on the second row. So the highest frequency is 19. Kung ingani gani, kung frequency ang given, ay nyo lang i-identify kung asay pinakadako na frequency. In this case, the highest frequency is 150, corresponds to 150. So it means lang na 19 people has an income of 150 pesos per day. So kani ang pinakahamok na bilang. Therefore, 150 is the mode. Okay? Now, mode for the group data. So in case of continuous frequency data table, mode can be calculated using our formula. Z is equal to L plus F minus F sub 1 times W all over 2 times F minus F sub 1 minus F sub 2. So L here, it's the lowest limit of the model class. Okay, F is the frequency of the model class. W is the width of the model class. F sub 1 is the frequency of the class just before the model class. F sub 2 is the frequency of the class just after the model class. Okay, so the model class, kinsa man diyan si model class, ma'am? It's the one which has the highest frequency. So for example, you have there the table, and then you are asked to look for the mode of this given data. Using the formula, all we have to do is to substitute. Okay, L, this is Going back to the definition, L is the lowest limit of the model class. Before we can continue, we identify first kinsa si model class di ay nato. Ang model class nato has the highest frequency. So the highest frequency here is 19. Its corresponding data is 150 to 200. Okay, so lowest limit of the model class. This is the lower limit, this is the higher limit. So ang L nato is 150 plus ang F nato given in here the frequency of the model class. The frequency of our model class is 19. So you have here 19 minus ang atong F sub 1. This is the frequency of the class just before the model class. So before the model class, you have 100 to 150. Its corresponding frequency is 5. So you do have it in here, 5 times ang ato ang class width. So ang class width, inyo lang isubtract ang lower limit o ang higher limit. So 150 minus 100, 200 minus 150, 250 minus 200, and so on. That will give us 50. Then dari kita sa ubos, 2 times our frequency, okay, which is 19 minus ang atong lower frequency sa atong limit sa atong class before the modal class is 5. Okay? Minus ang frequency sa atong model class, ang frequency sa atong class after the model class, which is 200, 250, ang iyang frequency is 3. So if you are to simplify that one, the answer will be 173.33. Okay, that will be our mode in this example. You have to remember this because majority of these questions, I mean these type of questions will eventually come out in the board exam, especially sa LET, no? So naana yung mga questions na madami, the median of the mode and okay, pero the only thing that I have remembered, I think it's the most reliable measure of central tendency. If given ang extreme values, the answer there is mode. Pero if mulaong lang na the answer there is median. Kung moingon lang na the most reliable measure of central tendency, ang answer is mean. Pero pag mulaong na the most reliable measure of central tendency given or with extreme values, the answer is median. Okay, I hope it helps, no? Okay, now the mode for group data. There may be no mode if no value appears more than any other. So kung walay magbalik-balik na value, wala tay mode. Pero kung naatay duha ka mode, it's called bimodal. Kung naatay tulo ka mode, it's called trimodal. If na kay four or more modes, then it's called multimodal. If there are more classes with the same frequency, then the mode will be more. Okay, for example, ang imong data is 10, 20, 26, 10, 15, and 20. In this case, we have frequent data which is 10, okay, kaduha siya, and then 20, kaduha pod. So they have the same frequency, therefore we have two modes. This is bimodal. Then if mag-add kog data diri, suppose na ako 17, 26, onya, 11. So naatay again another frequent nga number which is 26 lang gihapon, no? Si 10 kaduha mo exist, si 20 kaduha mo exist, so 26 kaduha mo exist. They have the same frequency. So hence we have a trimodal. Pero kung magdugang na pud ko diri 15. Okay, so naanatay upat ka mode. Si 10 kaduha no exist, si 20 kaduha mo exist, si 15 kaduha mo exist, si 26 kaduha mo exist. So, it's called multimodal na. But if this will be the case, say for example, na anak ko'y 17, o niya anak ko dari 23, 24, 25, then I have in here again 23, and then I have here 23 na pod. If you are to spot it, si 23, okay, katuyo si Jamo exists which has a higher frequency compared with the others. So, isa lang ang atong mode diri, si 23 na. No? Ang inyong dumduman sa frequency ang pinaka nagbalik-balik or has the highest frequency. Okay, now a common approach to this is grouping method or finding the relation of mean, median, and mode. The relation can be explained as ang mode nato daw is just equal to 3 times the median minus 2 times the mode. This method can be used to calculate accurate mode for bimodal, trimodal type of data. Okay? Pwede din ninyo ni gamiton sa kanina example. Alright, now let's move on to the measures of dispersion. But before that, recall kita sa measures of central tendency. The mean, that is the average or the expected value. The median, that's the middlemost or ang naa sa tunga na value once you arrange the data in ascending order. Pag-add ang number of observations, arrange in ascending order, ang naa sa tunga will be your median. Pag even ang number of observations, arrange in ascending order, ang duha ka value nga naa sa tunga, i-add nimo, i-divide by 2, that will be your median. Ang mode nato, that's the most frequent or ang pinaka nagbalik-balik na value sa dataset. So it could be bimodal kung duha ka mode, trimodal kung duha ka mode, multimodal kung 4 or more na ang mode. Okay, so let's have the measures of dispersion and the variation. It's called dispersion or variation because these values will tell you how scattered your data is, how dispersed your data is. The observation deviating from the central value is called dispersion or variation. This is called as variability of the data. The means are the same. Okay, the blue and the green lines are more heterogeneous if you are to see. The blue and the green line are more heterogeneous and the red is homogeneous. Variability or dispersion is the measure to express the extent to which the scores are different from each other. Unsay pasabot nam ng low variability o high variability. So for example, ang ani ang imong ang data 10, 11, 12, 13, 14. So if you get the difference of each datum or each value in this data set, one lang. So it has low variability. Dili kaayo kung katag. Pero kung ang imong data is let's say 10, 15, 25, 41, 60, this has a high variability because if you are to get the difference of each data, dagko kaayo ang ilahang diferensya. So mas katag ang imuhang data. Okay, now we have the measures of dispersion, the range, the mean deviation, the standard deviation, and the quartile deviation. Pero ang pinakagamit lang ani is ang standard deviation o ang variance. But we'll focus on three lang diri siguro. The range, the variance, and the standard deviation. Kay kanilang man ang usually ginagamit sa statistics. If you have tried doing statistics or creating a research, paglantaw ninyo sa results and discussions, typically si mean o si variance ang pinakagamit. Okay? Mean og standard deviation rather. Mean for the central tendency, standard deviation for the variation. Okay? So let's have the range. The range is the difference between the highest and the lowest value in the data. So all you have to do is identify the highest value and the lowest value. Then you subtract. For example, you have 3, 5, 6, 7, 6, 8 until 13. So all you have to do is to spot the highest data is 13, the lowest is 3. So 13 minus 3, that gives you 10. Therefore, the range is 10. Another example, if this is given by interval 0 to 10, 10 to 20, 20 to 30, 30 to 40. So the highest value is 40, the lowest is 0. Get its difference, 40 minus 0, that gives you 40. Ana lang siya to get the to calculate the range. That's why its advantage is it's simple to understand and easy to calculate. I think this is one of the easiest measures no that you will be calculating. Pero, this is not suitable for deep analysis and in case of extreme values. Kung naanay mga dinaggo kaayo na mga value, it's not recommendable. Okay? Now, let's proceed to the standard deviation. It is the positive square root of mean of the squared deviations of values from the arithmetic. So, kung naana kay variance, naana kay value ni variance nimo or kaning si sigma squared, pagkuha nimo sa standard deviation, Okay? Kung ano mo sa standard deviation, square root lang si sigma. Square root lang ang value ni variance nimo. Okay, the most commonly used and denoted by SD or sigma. This is the formula for discrete data. Pag discrete ang data, kani imong gamiton. Pag grouped or continuous ang data, kani ang imong gamiton na formula. Kilayan lang nimo pag grouped or continuous, in continuous kay naa na involve nga frequency. Okay? In most of the cases, n minus 1 is used instead of n as a denominator. This is called as Bessel's correction as it gives an unbiased estimator of the population. But here's the catch dire actually. Kung mogamit kag sigma, that's actually for population standard deviation. So ang imong denominator is n. Pero kung mogamit kag s for standard deviation, ang imong gamiton is n minus 1. This is for the statistic sample. Okay? Kibali, dili nimo hudton tanan data or entire population din mo is-isahon. Basically, you will just be getting a sample. Okay? For example, sample example, given are the data of blood cholesterol levels of 10 persons. Calculate the standard deviation. So here are their corresponding cholesterol levels. The steps are prepare a table, then calculate the mean of the data. You will be using the formula of the mean that we have discussed, no? And then in this case, the mean is 264.7. So we have assumed nga na-solve na ang mean. After that, you compute for the summation of x minus the mean squared. X is the corresponding values of your variable. This bar x is your mean. Okay, so let's try. First column, the values of your x. If you are to sum it up, the answer is 2,647. Then you have x minus the mean. So 240 minus 264.7, that's 24.7. 245 minus 264.7, that's 19.7. 255 minus 264.7, that's negative 9.7. The same thing that you will do for the following data. Then you sum it up, the answer is 264.7. After that, the values here on the second table will be multiplied to itself, no? As you can see, kani siya ato lang gi square. So kaduhaon kibali nimo kani siya. So negative 24.7 times negative 24.7, that's 610.09. Next na pod, negative 19.7 times negative 19.7, that's 388.09. And then after na po, negative 9.7 squared or negative 9.7 times itself, you will have 94.09. The same process for the given values below. Then you sum it up, you will come up with um, 1,564.1. Unya, kanina mga value, imo na siyang i-substitute sa formula diri sa taas. Then, you will have your answer, your standard deviation, which is 16.01. So, once you have the standard deviation, dali na lang dayon pag-compute sa variance. Square lang nimo si 16.01, that will be the value of your variance. Unya, kung variance pod ang given, kuha lang ang square root ana na value, that will be the value of your standard deviation. Okay? Okay, another example. Given are the data of weight of adolescent girls. Calculate the standard deviation for the continuous frequency data or the group data. In this case, ang formula na gigamit is kaning sa first one kay discrete data man ang example. Pero sa ating example karon, it involves frequency naman, so we'll use the formula for the grouped or continuous data. Mogamit gahapon kita ng table para mas dali. Okay? So you have there x values or its interval, the frequency, the midpoint. So for the midpoint, just have to add the lower limit and the upper limit, then divide by 2. 60 plus 64 divided by 2, that's 62. 64 plus 68 divided by 2, that's 66. 68 plus 72 divided by 2, that's 70, and so on. And then for the frequency, imo lang na siya i-add, you will have 28 in here. Then once you get the midpoint, you multiply the second column to the third column to have your fourth column, to have your entry on the fourth column. 10 times 62, that's 620. 09 or 9 times 66, that's 594. And then 2 times 70, that's 490, and so on. So we still have to add this because then again, gamiton gihapon sa summation of x times f sa ato formula, you have 1,852. Then each values here in our midpoint will be subtracted by the value of our mean, assuming that the value of our mean is 66. So you have 62 minus 66, that 66 ba? Okay, let's assume lang. So it gives us negative 04.14. Then 66 minus the mean, that's 0. 70 minus the mean, that's 3.86. And then 74 minus the mean, that's 7.86. Tama ba? 74. Let's just try to check this one. 74 minus 66 point, uh, wala ba? 66 point something. 62 minus 4.14. Okay, that's 57.86. We'll try 57.86. 62 minus 50, for a while. 62 minus 57.6. Okay. Baliktad again. 62 minus 4.14. Okay, 57.86. 74 minus 57.86. Okay. The mean here is unidentified, but let's just assume na it's given para dili kita malangan. Okay, you double check it na lang. Same formula lang gyapon itong naa sa taas. Then once you have the answers in here, you multiply it by itself or you square that one. Negative 4.14 times itself, that's 17.40, times itself, that's 0 gihapon. And then once you have all the entry in the column number 5, you then have to multiply it to its frequency, to its corresponding frequency. 17.14 times 10, that's 171.40. 0 times 9, that's 0 gihapon. 14 times 0.9 times 7, that's 104.3. 61.78 times 2, that's 123.56. So you sum it up, you will come up with 399.26. So once you have these digits, all you have to do is to substitute it to our second formula. Then you will come up with the answer, which is 3.78. As for the variance, square lang ni mo ni siya. Square ni 3.78, that will be the value of your variance. And these are the characteristics of the good variation, which we have actually observed in the previous example. So it's rigidly defined, it's easy to understand and calculate. Once you have identified if it's discrete data or if it's continuous or if it's frequency ba, so easy na dayon. And it should be based on all observation. So tanan, isa-isa ko nimo, tanan part sa population or the entire population itself, in the entire observations. If you take out the sample, so tanan samples, tanan datom dito as imong dataset ma-include sa imong calculation, and it's amendable for further algebraic treatment. It should be affected by sampling fluctuations, and considering all the above factors, standard deviation is considered as the good measures of variation. That's why kung makakita lagi mo pag sa stats sa research, or have you ever conducted a research, or if you have you ever tried reading a results and discussion of a particular research, ang kasagaran didto mugawas na measure of variation or ginagamit na measure of variation is the standard deviation. As for the measure of central tendency, ang kasagaran ginagamit is the mean. Wait, let me show you something. Pakita ko tong akong gihimo. Okay. Just like in here. For a while. Okay, see? So, the most commonly used measure are the mean and the standard deviation, mean standard deviation, mean standard deviation, ana siya. So, kana sila ang pinakagamit ka in statistic and in research. But it does not mean nga dili important itong uban. They have their functions as well. Okay, so that would be all for today's meeting. I hope that everybody have learned. Thank you so much for joining our class. Goodbye and God bless us all.